Hi everybody, this is project video number 1 for the multi-sensor electronic learning board. The Kickstarter link is below in case you're interested in checking it out. For the better part, this schematic is going to use blocks such as this. I've gone through all of the schematics in the product videos. Those are linked to the project updates. They will be in the manual as well. So we're going to talk about what's going to go on with this. This is going to be a clapper circuit. We're going to use our microphone, an amplifier, 555 timer in monostable mode, and an LED. Now this project video will actually be broken up into 2 videos, the hardware, and I'll include a really simple video with an interface with an Arduino, but that'll come a little bit later. So this is video 1 of 2 for project 1, if that makes sense. So here's our microphone circuit. We have talked about it before in project video number 1, product video number 1. When we speak into the mic, or when the mic senses noise, what's happened is we get a very, very, very small signal on the 0 volt line coupled to the AC pin, coupled across this DC blocking capacitor. We only see a very, very, very small representation of the sound that's heard by the microphone at the AC pin. This is 10K, sorry. Again, talked about in product video number 1. So in order to amplify that, we want to bring that up closer to 5 volts. We'll connect the AC pin on the main pin block to the A1 plus pin on the main pin block. From there, we can turn this little tiny signal into a 0 to 5 volt signal. It'll be basically an amplified version of what we see at the microphone. And we can tune the sensitivity, we can tune the gain by turning the gain 1 variable resistor. So we can make this amplify it a little bit, or we can amplify it a lot. In any case, when the signal reaches almost 5 volts, about 4 volts, what will happen is we can use that signal to activate our 555 timer in monostable mode. But before we do that, we're going to connect our A1 out pin to the LED pin. And this is just going to act as an indicator. This is going to help us to calibrate. So we're going to speak into the microphone, turn the gain 1 resistor, and we can turn it to high sensitivity or low sensitivity. And if we have it in low sensitivity and we speak loudly into the mic, the LED will light up a little bit. But if we have it at high sensitivity, it'll light up even if we're just talking quietly. So we're going to do that in just a minute on the board. Once we're done tuning the output of the amplifier, we're going to connect the output to the in pin on the main pin block, and that's the transistor-based switch on the 555 timer in monostable mode, and that will turn, once we speak loudly into the mic, depending on our sensitivity, we will see at the output of the 555 a single pulse. So when we speak loudly and the voltage reaches about 4 volts, we're going to turn this noisy wave into a single pulse. And we can adjust the length of this pulse by turning the DLY variable resistor. We can make a really short pulse, we can make a really long pulse. And so what we're going to do there to calibrate that is we're going to connect the DLY output on the main pin block to the LED. So when we have it tuned the way we want, we clap, and the LED will turn on for however long we've tuned the pulse duration on the output of the 555. So let's actually do this on the board. The first thing you're going to want to do is make sure that you have your microphone selected. Place the 2-pin jumper over the mic pins. Once you're done that, power it up. The AC pin is on the right side of the main pin block. Use a female-to-female connector to connect to the A1 plus pin. From there, take another female-to-female wire connection, connect A1 out, the amplifier output, to the LED pin. The LED is right here. Hello, hello, hi, hi, hi. So it's pretty sensitive right now. You can see it blinking when I talk. hello, hello, hello. So we don't even really have to tune it, but we can turn the sensitivity down a little bit. The gain 1 resistor that determines sensitivity is right here. And what I will do is I will start fiddling. Hello, 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 hello. Let's turn it the other way. Hello. Hi. Hello. 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 So now it's barely lighting up when I talk. I can decrease it even more. Hello. 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 Now it's barely lighting up at all. So what if I give a clap? That's good. Sensitivity is low. So now from there, I take another female to female wire connection. Actually, I'll put that aside right here. I'm going to take the A1 out pin, disconnected from the LED pin, and I'm going to connect it to the in pin of the 555 timer. I'm going to take the secondary female to female connector, and I'm going to connect it to the DLY pin and connect it to the LED. Alright, so now if I clap, oh, it heard me. So sensitivity is still too high. I'm just going to turn the sensitivity down a bit more. So you see, I can adjust the pulse width by, adjusting the DLY variable resistor. Now it's going to false trigger because I'm hitting the board and it's detecting that. So, hello, 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 hello. So now the pulse width is so short that it's actually kind of a useless circuit. So I'll turn the resistor right. Hello. I can keep turning it. Hello. So I can make this really sensitive. Obviously I can make it so that if I even speak across the room, it'll light up. Or again, I can adjust the sensitivity to make it almost not sensitive at all. Hello! So now the sensitivity is very, very low. So that's the conclusion of this video. Hopefully it made sense. If you got stuck somewhere, go back to the explanation on the whiteboard. It's just a matter of connecting a few pins, these are electronic blocks, to one another, and you're off to the races. Very, very easy to manipulate the circuitry on the board. So I will be coming back with a project video number 1, part 2, and that'll include me interfacing the same circuit with the Arduino board. Thanks for watching, everyone.